So yeah, I'm Mark Striebeck, engineering manager at Google, working on Gmail, managing the Gmail front-end development. Before that, I was on our internal testing tools and infrastructure teams, and at the very beginning of my time at Google, I'm now there for 6.5 years. I was on AdWords, our advertising system. When Sandrine asked me to give this talk, I didn't realize how much this talk will actually be pretty much about my career at Google. Because everything that is here was basically things that I did, many things that I managed, things that I was involved, to get us at Google from the point where testing, especially automated testing, was something that people sometimes did, sometimes did not. Some people felt very strong about, many people didn't care that much about, to the point where we are today, where it's really a part of our development culture, a part of our development process, where you don't have to ask people to write automated tests, people are just doing it. And so what I wanted to do was to do this talk a little bit because it's so much about the Google culture and how we do things at Google. And I found that I can do it very well with these 10 things we know to be true, and for formatting reasons, you can't see the 10th here. So these are things that there's an address. These are things that we believe at Google in, how we want to run the company, how we want to run our business. I don't want to go into details here because I will go into details later on when I do the talk. But the important thing is, as you can see from the note, is we actually revisit these things every now and then and update them, take one out if it doesn't make sense any longer, put a new thing in, or change them. The other thing that you might see is, if you look through it, there is some things that probably sound familiar to people with a lean background. Focus on the user and all else will follow. Really focus on the end user value, on the business value of any work that we do. Fast is better than slow. The last one that you can't see any longer is great or good is not good enough, something like that. The idea of continuous improvement, of continuously thinking we can do things better. We don't stop improving things. So there is quite a lot of things, again, where there's an overlap with lean. So first I want to describe a little bit the development culture at Google and the development environment. So the most important thing is, at Google, across the entire company, across the entire product, front-end, back-end, infrastructure, platforms, everything that we have one code repository, and it's completely open. Everybody can see all the code in the company. Everybody can change all the code in the company. One thing that we have is we have the process of code reviews. Every code that gets checked in has to have a review. And we have this concept of owners in various parts of the directory. So if you want to make changes to a lower level infrastructure piece, you can, but somebody from the team has to approve that change before it goes live. All the tools that we use are completely open. So the code review tool, for example, of course, is a web-based tool at Google. And I can see all the code reviews. My own, from other people, from anybody, from my team. We believe it's really, really important that this information is out there. If ever somebody needs access to a code review, needs to go back to a change that somebody else made, or reads the code review and there's maybe another change mentioned in the code review, people should be able to find this information. And the last one is important. We don't have binary dependencies, which means we build everything from head. For a team like Gmail, that's quite a drag. Every piece of infrastructure, everything that we build, not things where we just use a client library and we don't have to build the server, but we have to build all the client libraries, all other libraries, everything from scratch, everything from head. This is something that Google started from the very beginning, where the early engineers of Google believed that in the end they will get so many dependency challenges, incompatible libraries, whatever, that would be really, really bad. And one area where it actually would be bad is if you think about a company like Google with hundreds of thousands of servers outside, the last thing that we can afford is a bug that only shows up on some servers but not on others. Because on one server we have this library version, on the other server we have this library version. It would be a nightmare for us to maintain that. Democracy on the web works. We also have at Google, I wouldn't call it a democratic culture, but it's a culture where there's very little top-down management. So no big standards that are driven, no big programs are driven, this is what everybody has to do. We believe in delegating responsibility downwards, and really a lot or almost all of it. For our development teams, that means, for example, in Gmail, we have in Gmail 3 areas that we constantly have to improve, which is user adoption, user engagement, and money. So pretty much every project that we do in Gmail has to address at least one of the 3. So engineers don't sign up to work on a project and code a project that somebody else knows has some value, but engineers sign up in the end to improve one of these 3 things with their project. And if the engineering team realizes halfway through that whatever they do doesn't work or doesn't address this, it's actually encouraged that they are the ones who kill their project and say, look, doesn't make sense, we need to do something else, or that they found other ways. But we don't hold them hostage to some design, specification, whatever that they did at the beginning and says, no, you have to implement this. If we learn something, let's use it, and let's always make sure that we address our end user impact goals. So driving change here can, of course, be a challenge. And so what we have there at Google is this concept of grouplets, where people can spend their 20% time, as we call it at Google. Every engineer is encouraged to spend 20% of his time on something not his main project. And grouplets is one way people organize themselves around some subject that they feel very passionate about, that they want to change, that they want to implement, that they want to try out. So in this case, we had a bunch of people who were very passionate about testing and automated testing and unit testing. And so we created the testing grouplet. And the good thing is, again, the agenda of these teams is not driven by upper management, but they're very much behind it. So they give us the support. We get somebody who actually helps us, a program manager, to organize events that we want to do and other things. We can get money if we need money for prizes that we want to give out, or if we want to buy books for people. Anything like that, we get lots of support. But we have to drive it ourselves. We can't go then at some point to an Alan Eustace or a Bill Corrin and say, look, we figured this out, this is good, you now have to drive this. He's not doing it. He sends an email on our behalf saying, hey, we have this and this event, please participate. It's a great idea, but that's pretty much all. So where to start now? So just a little bit of background. In 2006, Google grew insanely fast in terms of products. I don't know if anybody remembers this time how many things we released since then in terms of people. I think after 1 year, we have this, somebody wrote a weird program at Google. If you go to /% on the Google network, you see the percentage number of people that are newer at Google than you are. Somebody thought it's a funny idea. After a year, for me, this number was more than 60%. So this is how fast Google grew at that moment. The source code, of course, grows, and the dependencies grow, because we write all our infrastructure ourselves. We don't use any commercial database. We don't use any commercial virtualization system or anything. All this is written ourselves. So the dependencies, as you can imagine, being so deep and having now so many products grow tremendously if you do that much work. At that time, QA was doing mostly manual testing. In fact, QA still had this idea of being a service organization, so they basically try to move around from team to team to a little bit testing here until they can release, and then they move on to the next one. Engineers could write automated tests. The infrastructure was there, the tool support was there, but it wasn't really encouraged. Many people didn't really care about it. You could not, in a code review, for example, tell someone, look, I like this code change, but you have to write a test. Like, people would have looked at you like, look, I just need to get stuff done here. Don't bother me with tests. But at that time, integration and release problems really started to show up. That some teams realized, wow, it's getting harder and harder for us to release, or we have to be more and more careful in terms of what changes do we let into our code base. Because again, you get many changes into our code base from other teams. And with the dependency tree that we have, you get changes into your code base without you even noticing it, because somebody makes this change to a lower level component that you just suck in as part of your dependency tree. So this became more and more clear. This was starting to slow us down. So one of the 10 things is it's better to do one thing really, really well. So when we started the testing grouplet, we figured, okay, there's so many things in the world of testing that we could improve, but we can't address all of them. There's unit testing, there's latency testing, performance testing, name it. But we wanted to have something that we felt passionate about, and we was, in this case, a bunch of engineers where we have experience and that still can make a difference. And so that's why we decided, despite the name, the very generic name of testing grouplet, we just focus on unit and developer testing. Not anything else. Because one of the main reasons was also that we believed if we improve this area, the other areas further downstream will definitely notice the difference. If it's QA testing, latency testing, if the code base itself is just stable and you can sort of run the basic functionality and nothing breaks in compilation, nothing breaks in the basic functionality of the tool, that would be a huge step already for us. And then, of course, you can be serious without a suit. First of all, Google is also a very T-shirt driven culture. If you want to get people to do something at Google, you have to give out T-shirts. So we have these events called Fix-Its, which is something not from the testing group, but something that we do at Google sometimes. The idea is you focus the entire engineering team of Google for one day on one thing. And think about it, we have today something like 10,000 something engineers. What a difference 10,000 engineers for one day can make if you can focus them. So we had from the testing group these events where we said, look, today we want to fix or we want to write this and this many tests. We want to bring the code coverage up to this level. And we prepared these really, really well that people didn't have to start in the morning figuring out what they're supposed to do. We had things like tech talks in the morning where people could go, where people were explained this is what you can do. We had lists prepared of files that have very low test coverage, where it should be easy to write a bunch of tests. We had people on all the sites that were there to help people, even pair program with people. So we wrote this for one of the fixes where we could just see literally on an hourly base, what are people doing and which offices are making people changes and which offices do people do participate. And then we organized tech talks with external people, and we tried to get everybody who has anything to say about unit testing and developer testing. We did internal tech talks from teams who did developer testing, just their experience with it, what worked, what didn't work, how they did it. And then, of course, you can't talk about this without the infamous testing on the toilet that I see some people. And it's literally what it's called. We had this discussion in our testing grouplet a couple of times, like, okay, how can we get this message, not just through a fix-it event or a tech talk or something, but how can we get the message out about testing? And somebody jokingly says, like, yeah, we should just put it on the toilet. And somebody, of course, in the London office thought this is a fantastic idea. And before we knew it, he just did it. He just created one of these flyers, which is a very sort of googly flyer with like data and all kinds of things with contextual text ads at the bottom where people can go to find further information. And we just put it up in the toilet. And we organized this very quickly worldwide, where we organized people who hang it up in the different offices in the different buildings and everything. And we got an enormous amount of feedback, a lot pretty negative. People literally complained, or some people literally complained about how dare you invade my private space. And it's like, look, you don't have to look at it. But people felt, but again, our goal with this was really not to educate people about testing. I mean, there were interesting tidbits here. Our goal was to make people talk and think about testing. And we definitely achieved that. People talked about it, and positively or negatively, it wasn't ignored. And then it actually took on a life of its own, like various news organizations, Forbes, San Jose, Mercury News, the Washington Post, people who visited the Google offices saw these because they're just on the public restrooms. And so they started writing about it, and it was interesting that they all got it. That they all said, like, wow, this is pretty much like Google culture. It's this quirky, kind of weird, always focused on engineering thing that they do. And so these were all the things that we did, where we educated people about testing, make them think about testing. And so at this point, we sort of stepped back and thought, okay, have we solved it? Have we done it? People know how to test. They think about testing. But nothing really changed. Although people knew it, they didn't do it. And at this point, it was kind of tempting to get this attitude, well, they just don't get it. But again, focus on the user and all else will follow. I think this is one of the most important things for a program like this, or any type of change program. If you are convinced you have something that makes people's life better, in this case, we thought we have something that will make engineering's life better, that will make development better. And if they don't do it, then you have to look for the problem at yourself. You do something wrong. You don't explain it right. You don't explain the benefits right. It's maybe not as good as you think. Whatever it is, you can't just sit back and say, yeah, we know it, but these guys don't get it. And so we really had to think about, okay, what did we do wrong? And so we really tried to figure out, why do these engineers not do what they know is actually the right thing to do, which is writing unit and automated tests. And there were two main things. Where to start? They had their development process, their code base. They just didn't know, okay, you gave us all this information. Testing, dependency injection, continuous integration, code coverage, all these things that we talked about. They just had no idea where to start. It was just way too much. And then some teams who actually did try it figured out, okay, I have a lot of legacy code. It's really, really hard to write good automated unit tests. So we had to figure out how to address these two things. For the first one, we created a program that we called Test Certified, which is basically a series of steps that people or that teams can take to get better and better at unit testing. And as always, there were T-shirts that people could get if they participated. And in this case, because it was these different steps, people got some weird potato hats for each step that they took. And so the first step was actually interesting. The first step didn't even require people to write tests. It was just set up a continuous build. We had a system that automatically collected code coverage, set up these systems, and at least know what your status is. And try to keep it, or try to make it green, but there was no requirement, oh, it has to be green all the time or 90% of the time. It was just people should get familiar with the tools and with the terminology and everything that they have to do. Then the second one was really, okay, start writing tests, start apply some of these things. And then in the, I think there's 6 or 7 steps altogether. So it became more and more complex, more and more concrete, higher code coverage. At some point we classified the test in small, medium, large tests depending on how much they affect, if they use the file system or not. And so then we got clearer and clearer what we want. But it was really the sort of step-by-step that was really helpful for teams, that they now could start with something and they had success fairly early on and didn't need to wait for half a year or for a year to finally see a difference. So that addressed the first step, that people now knew where to start. But they still ran into the issue of, at some point, they had to get sort of serious about writing unit tests, and they still had their legacy code. It was still hard to do it. And so this is when we started this group called the Test Mercenaries, which many at Google are not happy that we chose this name. And so this was an internal consulting group, the first one we ever had actually at Google, that basically embedded itself into teams to work with them on this. Analyze their code, starting to refactor the code that it's actually possible to write tests. Educate and train the team. They usually did something like talks to the team, and then they just pair programmed with each engineer to show them everything that they needed to know about how to write testable code, how to write tests. And they also tried to explain to people how to include this in their development process now, what needs to change. And this was something that in the end didn't work that well. And the main reason was that we just couldn't scale it enough. So for Gmail frontend, for example, it's interesting that I now work on Gmail frontend. At that point, Gmail frontend was one of the teams that we tried to work with. We embedded 5 engineers for 2 quarters in Gmail frontend. And they made a huge difference. They actually got Gmail from having almost no tests or very spotty tests to an area where Gmail actually felt much more safe about their code, the release and everything. But again, if you think about it, Gmail frontend is just a small part of Gmail. It's not even half of it. It's nowhere close to a quarter, actually. And then Gmail is just one of the products within Google. So there was no way that we could scale this to basically address all of Google. So we had to abandon this idea and say, look, this will just never work. We can't hire enough people, or we don't have enough time to do this across everything. The interesting part, what survived from this program, is that people speak at Google with lots and lots of pride about this group that we used to have, and they did crazy things. And so what was left from this is really that people realized, okay, A, this is important for the company, and B, they also realized, wow, there were some really great engineers who do it. Like, this is not something that some tester does, but they realized, wow, this is actually a great engineering thing to do. So we had to abandon this, and we basically had to rely on, at this point, on enough people know now about testing, enough people know it, they will have to spread it more organically within Google. It's nothing that we can really do actively to help this. And that actually worked pretty well. That the bigger teams at this point understood the value and the necessity of this. They now made the effort to sort of draw people in, ask for help, ask some teams that they know made progress here and says like, look, you have to help us. You have to explain what you did because this is important for us. So now problem solved. People know what to do. People actually understand what to do. They really drive. They make an effort to do it. Still not. One of the things, fast is better than slow. Somebody mentioned at the beginning, with this type of code dependency, building everything from head, if now something takes you to build 30 minutes or more to run your tests, well, you never do it. You just check in your code and you maybe run it afterwards or something. But you definitely don't do it anytime during development. I mean, it would slow you down way too much. So we had to address this too. And so this is something where I'm really, really proud of Google, that Google takes testing or internal development as a first-class citizen. So when we approached our executive management team with the idea that we need to do our builds and running the tests in our production environment, in our cool, expensive, really, really fast, highly parallelized production environment, they had absolutely no problem. Nobody says, no, this is just for making money and everything. You need to, no. It was totally okay. So we could basically, there was a huge effort to shift the entire process now into our production environment, making it highly parallelized, highly scalable. We built out of this, because we needed it, because we built everything, had a company-wide continuous integration system. We run all affected tests on a code change that comes in. So we have the entire dependency tree now literally in memory. And if a change comes in, we have to check, does this change affect the dependency tree? If yes, update it. Afterwards, check which tests have to run and run these. And run these, build and run these in parallel. And so people get the feedback very quickly if their change broke anything anywhere in Google. And then the next thing that we did is that we actually made it a pre-submit system. People didn't even have to submit to wait for the signal. They could actually say, look, I'm about to submit this change. We merge the change into the current head branch. If there's no conflicts, we ran the same thing. So people can get the information before they submit if they would break something. So at this point, we now have it down that people can run tests really, really fast. Can get the signal back really, really quickly, even before they submit. So we don't have to wait until something breaks and then fix it, but we can actually prevent it from breaking. And so today, I don't think these stats are even accurate any longer. Like, we have over 10,000 people who use it, and we execute more than 50 million, I don't know what the latest number is, of test cases each day on this system. So it's a hugely scalable system that we built. But one thing that then also came up was now people had to deal with things like flaky tests and other things. If you imagine you now run all the tests, especially if you make a low-level change, you now run a lot of tests anywhere in the company and something breaks. So now you need the information that why did it break? Was there anything wrong with the test? What was the error output? How was the binary built? Maybe there was something wrong there. There's a gazillion of things that come in or that can come in. And so when we built the system, we thought about, again, there's always more information out there. Try to build these open systems. So we built this test case or test results repository that we needed for the system anyway. And from the beginning, we said, okay, this needs to have, of course, a web UI. Everything at Google is a web UI. But it also needs to have an API and a query interface that people can do with this data whatever they want. And so then we decided, for various reasons, we actually integrate this in all the low-level tools that people use to actually build and run tests. So as a result, literally every build and test run is logged today. If a developer runs it on his machine from the command line, through Eclipse, through IntelliJ, if our automated system runs it, whatever, it gets logged here, and people can refer to it back. And as a result, that's probably something that many people know who ever worked on software. and whoever had to analyze a build failure or a test failure with someone else. Where at some point you start sending lots of copy-paste stuff around, the entire stack trace that you got, and then somebody asks you, okay, what was the command flag, how you build it, what was the environment, what was set in the environment, what type of machine did it run. This is all in the system automatically. So people now send just these URLs and say, like, look, this build failed, here's the URL. From this URL, people can see absolutely everything that happened on the machine. And now people started to use it in all kinds of dashboards, other systems that they now needed to display health of the system, progress, anything that they wanted, because it had these open APIs. And then what was interesting, again, Google engineers love data and love analyzing data. So people now started to use this system to actually analyze things like flakiness of tests. They wrote their own tools to figure out, is a test flaky or not, and mark them specifically, and then maybe ask the team who owns this test to fix the test, or maybe to delete the test if it's flaky and it just causes too much pain for everybody. Code quality, all these things. At this point, it was interesting for us to watch that now basically the Google engineering community took over the role to improve code quality and test quality. We didn't have to step in any longer. People understood the value of it, and they now understood what parts needed to be changed and how to make it better and better. So we could just basically provide the tools, leave them there. At this point, it's not that like testing is fantastic today at Google and nothing is broken, but at this point we could mostly step back and say, okay, the Google engineering community actually can take over from here. And so today, well, great just isn't great enough. So we could actually increase in many of our tools our release frequency. We have this idea on push on green. Every time your continuous build is green, you just push it out. But it was interesting, I mean, in the past, testing and code quality was the big hurdle. You needed to know if your code is even stable, that you could get it to this point. Today, that's not the bottleneck any longer to make it faster. So many teams were actually asked, including Gmail, to actually push less often, because we have impact on other teams, of course. We use many, many other services within Google. So if we push a new binary, we create different traffic patterns, whatever. And these other teams is like, look, we need a little more time to figure out if this actually causes a problem or not. And so what we found now is the main bottleneck right now for most teams at Google to actually release faster is actually the tools to release it, or the process how we release things. Gmail runs on an enormous amount of servers worldwide. That takes us quite a while to update all of them. And then to analyze if this now causes any issues. So we have to leave our binaries out there for some time, for a few days actually, to figure out, okay, is there a latency regression, a memory regression, CPU regression, any of these things. So that's the area that we have to focus on now to actually get it faster. For Gmail, interestingly, like we set up the system we use internally at Gmail, like a special system that we update with the latest code every hour now. So I can see when I work on Gmail, I can literally see the changes from the last hour live, and I can use them right away. And this is how much we trust now our test suite and everything, because yeah, if this breaks, nobody in Gmail can use Gmail actually. Which sometimes is funny because it means we don't get the notification that Gmail is broken because that goes via email. So we monitor the system really, really carefully. And we rarely have failures where just the message delivery fails and nothing else. So it actually works. But so this is where we now have to focus on. So in the whole concept of improving agility and delivery speed, testing and quality is really not the bottleneck any longer. There's many things that we can improve, but it's not the main one. And then you don't need to be at your desk to need an answer. So now we have to do all of this again, and we have to figure this out, how to do this for all these mobile devices. As you can imagine, like it's fairly easy to run a fleet of computers and even of web servers and web browsers in this distributed environment. That would be much, much harder for iPhone, Android. All these permutations that you can have, carriers, OS versions, anything. So we have to figure this out right now, how to get this in here as well. And so a couple of observations, and these are not observations that I think apply or to any type of this program or something. It's just something that we sort of step back at some point. Is First of all, changing the culture takes a long time. I mean, this was many, many years. And we weren't aware of this at the beginning. I don't know if we would have done it if somebody would have told us, like, look, this will take you 5 years to get anywhere. But yeah, it takes a long time. Because you really want to make sure, as I said at the end, we wanted to be at the point where we can let go, where we don't have to drive it, we don't have to remind people, people just do it themselves. Having the right change agents is really important. It needs to be people who are really knowledgeable, really passionate, and somehow respected. People actually take advice from these people and take it seriously if a person says, look, you should do this, not because I tell you, but because I did it here and here, and I did this and this. Bottom up is harder than top down. That's something that we had to realize a lot. But yeah, it sticks. People actually appreciate it much more, being a little bit part of this grassroots movement that it basically is, that grows and grows, and people feel much more part of it than if somebody top down says, okay, we now have to do this at Google, and in a year from now, overall code coverage has to be at 80% or something. So again, it's harder, but yeah, I mean, we could see that, again, it was much, much easier for us to let go at some point. And again, for any of these efforts, not to fall into this, they don't get it. We explain it and whatever, and then stepping back and sort of laughing about the stupid people, like, yeah, they don't get it. Like, again, at Google, we have engineers who are very smart and who want to do the right thing. So we always had to tell ourselves, if they don't do the right thing, then it's not their problem, it's ours. What are we doing wrong? What did we miss that we didn't do yet to actually get them to do the right thing? And then this last one is just to focus on one thing. This was hard enough to just do it for unit testing and developer testing, and this automatically span into automated latency testing and UI testing and all kinds of other things that people then wanted to do that we didn't even have to drive any longer. But it was really important to just focus on one thing and just focus on the next step instead of trying to change everything at once and trying to address everything at once. And then the last one that I think is important for something like this, especially if it takes for a long time, don't take it too serious. Like, you can't just constantly be the very concerned, very serious person in your organization who remind people, look, it would be great if you do it. Like, you have to be able to laugh about it. You have to be able to get other people to laugh about it. I think, again, it's a culture change. And culture means you have to be able to laugh about things. So it was actually really important for us that this is something that we did, again, with testing on the toilet. We took it to some extreme end of this. It can't be too serious all the time. And so then I thought a little bit, before I came here, and then especially after our dinner last night, I thought a little bit, okay, so where's the overlap with Lean here, which is what this conference is about. And so I came up with 3 questions. The first 2, I have a couple of opinions. The last one is something that I would like your opinion. So is Google a lean company? I get this question a lot. Is Google a lean company? Is Google an agile company? And I always tell people, if you go to Google, if you observe how teams work, you wouldn't think so. You wouldn't think that they use any type of progress. Because people do, again, we delegate responsibility downwards. People can use whatever development process they want to use. Iterations or not iterations, backlogs, pair programming, whatever. We leave it up to the team as long as they deliver. On the other side, I think the culture of Google, how we run the entire company, is probably one of the most sort of lean or agile types of cultures that I personally experienced. The focus on continuous improvement, the focus on the end user, the focus on small teams and empowering small teams, I think is very much what the lean and the agile community is about, and it allows us to not have a lot of artifacts or defined processes that you normally need to enforce something. This was a lesson that I had to learn when I came to Google, for example. I was before very active, and even afterwards, in the Agile community. And one of my first projects that I worked with, we had an iteration planning meeting. We discussed a certain feature, and it turned out to be really, really expensive. And so at some point, with my Agile background, thinking, okay, that's a decision for the product owner. I turn around to the product manager and ask him, okay, should we do this or not? You know how much it costs you. You know how important it is. What does this guy do? He turns to the tech lead and says, what do you think, Ray? Should we do this? And so I was ready to step in and say, like, hey, guys, this is like separation. You have to decide the product side. You have to decide the technical side. But then I felt, okay, I'm new here. I don't want to do this. And so I talked to the product manager afterwards, and I was like, look, what should I do at this moment? Like, I know that Ray is as dedicated as I am to the overall goal, and this was to increase the sign-up adoption rate of AdWords, the project. He says he knows what the goal is. And it's not the goal to write this cool wizard or something. He knows what the goal is, so he has this in mind. And he has all the technical background to know if it makes sense to do it now or later or not at all. So instead of me asking him to give me all the information to make the decision that he would have made in the first place, I just leave it to him. And so this was one of the lessons that I had to learn, where we just don't need it at Google, this separation that you have in many agile processes, where somebody just takes care of the business side and has this in mind and sort of drives the engineering team. At Google, we just made the engineering team drive that themselves. So I think that's where Google is sort of a very lean and very agile company. What could Google learn from lean? I think there are many things. Google is, I didn't really describe it, but I think it came through. Google is an insanely pragmatic and fast company. We make decisions really, really fast. We want to move forward really fast. A lot of the analysis tools of lean, a value stream mapping, a waste analysis, anything like this, would help us actually every now and then to step back and use some of these tools to actually get an idea, okay, this is how we work. This is how our end-to-end process works. This is really where the big wastes are. This is where the real bottlenecks are, and focus on them. I know that we don't do that enough. And we had a couple of examples at Google where people with this background did this and had actually big success with it, where the teams were impressed, like, wow, you analyzed this really well, and now we know what we have to focus on to improve things. So I think there's a bunch of things that we can still learn from the lean thinking, and again, lots of the work that went into to actually analyze processes and improve processes and improve throughput. Because we just do it because we figure out this is broken and everybody rallies to fix it, and then we do the next thing and never the stepping back. And then the last thing, what could lean learn from Google? That's really something that I basically want to open up and ask you or any other question that you have about this. And before we go to the questions, anybody observed anything in the presentation? I only used 9 of the 10 things that we know to be true because I couldn't map one.
Which one did you not map?
You can make money without being evil. I could not figure out any way how to put that into an internal testing concept. But that's okay. Okay.